So far in this unit, we've reviewed exponential functions, and you've seen those already in Algebra 1. Today we're going to start logarithmic functions, and you have not seen these before. The reason we look at logarithmic functions with exponential functions is because a logarithmic function is the inverse function of an exponential function. And we have already looked at inverse functions. So remember, if we think about inverse operations, if I wanted to undo raising something to the x power, I would use a logarithm. Okay? So this is an example of something that's in exponential form, and this is the example of that same thing in logarithmic form. What I want you to notice is that the exponent here is 3, and over here in logarithmic form, 3 is over here by itself. So what helps me switch from exponential form to logarithmic form is thinking the exponent is always equal to the log. And then we also see that the base of the log, remember how we called this part right here, the b, that's for the base. We also call this little bitty number here on the word log, we call that the base. So I'm going to have exponent is equal to log base, and here we have 10. And then the leftover number is what goes after the log. Okay, so in general, what we're going to do is we're going to have, if I have some base raised to some exponent, and that is equal to some number, I'm going to call that y. So in variable form, that would look like this. B for base, x for the exponent is equal to y. I'm going to write that in exponential form. I'm sorry, that's exponential form. In logarithmic form, I would write the exponent is equal to log whatever that base number is, and then that leftover number y. With the variables, it would look like this. X equals log with the base b, and then of y. Okay, so that's the formula, or that's what we're going to use to help us convert back and forth. Converting back and forth is very important. We're going to use that to help us solve equations later on. All right, so all we're going to do is practice rewriting this in the log form. So this is an exponential form, so I'll always start with the exponent. Here the exponent is 3, and that's equal to log, and the base. So what number had the exponent on it? That was the 5. That's what we call the base. And then I put the 125. So I'm just switching the form. All right, so this one, the exponent is 2, and that's equal to log base. 8 was our base, so that's log base 8 of 64. And then in part C, we would have the exponent, which is 3, and I'm talking about this 3 right here, equals log base 3. Base 3 is that one. Oh, that's not very neat. Log base 3, and then we're going to have of 27. Okay, so the way I read that is 3 equals log base 3 of 27. So I'm going to pause here, see if you can do these bottom 3. Even though they have fractions in it, it works the same way. I'm going to pause, and then you can pause the video and then unpause when you're ready. Okay, so this is what you should have gotten when you rewrote it in log form. Notice that everything stays in the same structure, right? It doesn't matter what's in the exponent, even if it's a negative or a fraction, right? That comes first, and that's your exponent is equal to. And then the base, again, no matter what that base is, whether it's a whole number or whether it's a fraction or anything like that, that's going to be your base. And then again, what comes after the log is whatever is after the equal sign. Okay? So hopefully you're okay with changing that into log form. Now we're going to go backwards and we're going to write from log form into exponential form. Something that's kind of silly that helped me when I was learning this in high school is I thought of whatever base was on this log, I thought of this G as this long leg, and this G kicked the B all the way, kicked it so hard over here across to the other side that it bumped up that X. So all I had on the left-hand side still was Y, and then it was B to the X power. So that got kicked all the way up there. So if that helps you, if you're a visual person, then that's fine. If not, keep in mind that we have the base is 3. The exponent is what it's equal to, so 3 to the 4th power, and it's going to be equal to whatever's after the log. Okay, so let's do that again. So the base is 7, because that's what the base of the log is. It's equal to the exponent, so 7 to the 2nd power equals 49. Okay, or I'm going to do the kick thing. So if I kick this 10 all the way over here, I'm going to have 10,000 equals 10 to the 4th power. Okay, so either way you like, you do that. So again, pause the video, do these bottom 3, and see if you get the same answer as me. Okay, so again, you should have gotten these answers. And remember, it doesn't matter what the exponent is or what the base is. Those can be fractions or negatives or anything like that. Now, something I want you to keep in mind is the exponential form should make sense. So here, 7 squared equals 49. That makes sense. We know that if we do 7 to the 2nd power, that's going to equal 49. Same thing over here. If I have 10 to the 4th power, remember, 10 to whatever power just means that's how many zeros I'm going to have. So notice that I have 1, 2, 3, 4 zeros, and that's 10,000. Okay? Also remember, when we have a negative exponent to the negative 3, that's the same as doing 1 over 2 to the positive 3. You remember that doing that? And that's where we're getting the 1/8. So if you see something raised to the negative power, you should see it flipped around. Another reminder about exponents is that anything raised to the 1st power is itself. Is that anything? So whatever that happens to be. So when you see log base, whatever number that is, to the same number, you know that your answer should be 1. And then same thing here. Anything raised to the 0 power, remember we said that in one of our videos, anything raised to the 0 power is always 1. Okay, so those are reminders about exponentials, and that's why some of these logarithms, when we look at those next time, it's going to make more sense of why logarithms are always equal to certain numbers. All right, so this is another going back and forth between the two. I'm going to save that for in class. You can do that on your own, or you can wait till class. Okay, so now what I would like to do is talk about solving for n. All right, we're going to use what we know about exponents and logs to help us figure out what the variable should be. So far up to this point, we've just been switching forms, but now we're going to use it to solve for a missing variable. So I'm going to try to do this without a calculator, and then I'll show you how to do without a calculator. So without a calculator, I don't know what log base 10 of 100 is. So I'm going to change this into exponential form. So I'm going to say the base is 10 raised to the exponent, which is just n, and I know that's going to equal 100. So I can ask myself, 10 to what power gives me 100? Well, didn't we just say that 10 raised to the whatever power it is, that's how many zeros? Well, I have 2 zeros, so I know this would be 10 to the 2nd power. So that means my n has to equal 2. So I know that log base 10 of 100 is equal to 2. All right, let's do the next one. Same idea, I'm going to switch it to exponential form. My base is 2, exponent is n, and it's equal to 16. So 2 to what power equals 16? Now, if you don't know this, you can do some guess and check with your calculator and just start plugging in numbers. But here we're going to have n is equal to 4, because I know 2 to the 4th power is equal to 16. So if I had 2 times 2 times 2 times 2, that would equal 16. All right? Now notice in these next two, the n is in a different spot. So we're still going to change it to exponential form, but we're going to do the base is 9, the exponent is 2, and that's equal to n. Well, this is even easier. I know what 9 squared is. That's 81. So I can solve that pretty easily. Same thing here. I'm going to do base is 2, exponent is 5, and that's going to be equal to n. So 2 to the 5th power is going to be 32. And remember, I got that by doing 2 times 2 times 2 times 2 times 2. That's how I'm getting 32. Okay, so now let's look at some other ones where n is in the base. So this is asking us the base is n, the exponent is 3, and it's equal to 125. So I want to know what to the 3rd power gives me 125. So again, if you don't know your perfect cubes, you might need to do some guess and check. But n should be equal to 5. I know 5 to the 3rd power equals 125. Because 5 times 5 times 5 equals 125. All right, so let's do the same thing here. N to the 6th power is equal to 1 million. 1 million has 6 zeros. And this should look familiar. If I have 6 zeros and my power is 6, then this n has to be 10, because 10 to whatever power is going to have that many zeros. All right, and then these last two are kind of a mixture. So we're just changing it into exponential. So n to the negative 2 power equals 149, 1 over 49. Remember, we said a negative exponent means that this is flipped. So this is like 1 over n squared. And we're trying to see if that's equal to 1 over 49. So if I look just at the denominators, I have n squared and I have 49. So is there some number raised to the 2nd power equal to 49? Yeah, 7, right? So I know that 7 would be my base there. And then our last one, even though this looks intimidating, all right, we're saying, what's our base? 1/2. I'm going to put that in parentheses. Raised to the n power equals 16. Okay, so again, if I wanted to flip that 1/2 so that it was 2 over 1, then the exponent would become negative. If that's confusing, then don't do that. But just hear me out. So this is like 2 to what power equals 16. And I'm going to put a question mark here. So 2 to what power? So 2 to the 4th power is equal to 16, right? So my power, which is negative n, has to be the same thing as 4. Well, I don't want negative n. I want positive n. So I would divide both sides by that negative 1. And that would give me negative 4. So I would know that n, what goes right here, n is equal to negative 4. And that makes sense, right? If I would do 1/2 to the negative 4 power, that would give me 16. Alrighty. So now we're moving on to the calculator. So if you don't have your calculator, pause the video and go get it. All right, so we're going to do log base 10. Notice that all of these have the same base, log base 10, because that's the button that your calculator has. It won't say log base 10, it'll just say log. So you want to look for that button on your calculator. And we're just going to practice plugging that in, and we're going to round to the nearest whole number. All right, so if I type in log, so I hit the log button, and then 79, it should give me 1.90 or 1.89 something. So if we round to the nearest whole number, that would be 2. Okay, so then over here, again, you're just typing the log button, and then you're typing in 21,050. and that gives us approximately 4.32. So the nearest whole number would just be 4. Okay, so practice the next two on your own, see if you can do that. Pause that video and then come back and check. Okay, so you should get, I noticed that I wrote the whole decimal that I got, and then I boxed in what my numbers round to. So if you didn't get those, then make sure to check with me, and then we'll figure out what you're doing wrong on your calculator. Okay, so now we're going to actually use all this information to solve equations. Okay, so notice that all of these equations have a base 10, all right, and that's because we're going to be using the log base 10. So these are exponential equations, and I'm trying to figure out 10 to what power gives me each of these answers. So I can't just look at that and figure out what that answer would be. It's going to be some kind of decimal. So notice that we're going to be rounding answers to the nearest hundredth. So in order to solve this, we're going to change these into logarithmic form. So I'm going to start, x is my exponent, so I'm going to have my exponent equals log base 10 of 12. So this is just like what we just practiced in a calculator. So I'm going to type in log of 12, and that gives me that it's about 1.08. So I have solved this equation with the x in it by using my logarithm. So this is the inverse operation part of what we're doing. So this helps us undo something raised to the x power. So again, I'm going to write x is equal to log, my base is 10, of 3,588. So all I do is type log of 3,588 into my calculator, and we get that. Okay, so again, try those on your own and pause the video and come back and check your answers. Okay, so these should be your answers. I've boxed in my rounded answers. If you're not getting those answers, then it might be how you're typing it in. So for example, on this red problem E, if you typed in log and then you typed in 1 and then divided by 1085, depending on your calculator, it might want you to put parentheses around it. Same thing with this green one, F. You might have to put parentheses around it, and it might do parentheses around that. So just be aware of your own calculator and how it works. If you're using the ones that we have in class, then you would use the fraction button to put those in. Okay, so make sure to bring these notes to class so we can practice some more.